Hey, what's up? It's Shahien Shahkar again, and we're going to be talking about linear systems today, and it's an algebra, and it's going to be so awesome. So, what are linear systems? Well, the idea is that we have two lines, linear line, okay, that are going to be crossing at some point, okay? So, the solution is like, where are these two lines crossing, okay? And so we're trying to figure that out. Now, let's say I had two equations for lines. One of those lines, let's say, was y equals 6 minus 2x. And this is really similar to slope-intercept form, which is the y equals mx plus b format. But I'm going to go ahead and leave it like this for now. And we have 7x minus y is equal to 3. This one's very similar to standard form. Actually, this is in standard form, okay? If you prefer seeing the top one in slope-intercept form, I could totally show it to you like that, which would be y equals negative 2x plus 6. Okay? Now, I'm going to go over linear systems today, and we're going to be doing it in the substitution method. Substitution method means I'm going to be plugging in for something. Okay? Now, in both of these cases, these are two lines that are crossing into each other. So what I'm trying to do is see where they cross. Now, do I know the value of x? No, not yet. Do I know the value of y? Not exactly, but check this out. I do know that the value of y is equal to negative 2x plus 6. Oh, snap! So if that's the case, then if I know y equals negative 2x plus 6, I could actually replace this y, let me do it in a different color, I could actually replace this y with the value of y here, negative 2x plus 6. So let's take a look at what that would look like. I'd rewrite this one right here, okay? So I'm rewriting it as 7x minus, okay, now here's the gold, y is going to be rewritten as this, because that's what y equals, right? So now I've got negative 2x plus 6, and then this is all equal to 3. So all I've really done is replace this y right here with this polynomial, okay? That's all I've done, all right, with that binomial. So now, check this out. I'm going to go ahead and solve for x like a boss. So here I go. I go ahead, and the first thing that I do is I distribute this negative, or this negative 1, which is hidden there, into the parentheses. Okay, using the distributive property, negative 1 times negative 2x gives me a positive 2x, and negative 1 times negative 6 gives me negative 6. Okay? Since this is a positive 2x now, because negative times negative is a positive, I've got 7x plus 2x minus 6 is equal to 3. And so then I just go through regular isolating my variable in order to solve for this. I put together my like terms. 7x plus 2x is 9x. And then I actually go ahead and add 6 to both sides, because this was a negative 6, these cancel out, and I'm left with, are you ready for this? 9x is equal to 9. Okay? Division property of equality, I end up with x is equal to 1. So, the value of x now is 1. If that's the case, which it is, because we just showed that, I'm going to go ahead and plug in 1 into either of these equations. It'll prove true for either one, if we've done it right. I'm pretty sure we did. So I'm going to put it into this one, okay? So I'm going to rewrite this equation over here. Y now is equal to negative 2 times, what did we say x was? 1 plus 6. What's negative 2 times 1? Well, it's negative 2. So I've got y is equal to negative 2 plus 6. That gives me y is equal to positive 4. Just checking, if I say that x is 1, that would mean 7, and y is 4, what's 7 minus 4? Oh my gosh, it's 3. Holla! So anyway, I was going to say balla, but that's me on the basketball court, because I'm a straight b-ball fiend dog. Anyway, so let me show you another version, not another version, but another example of this. So erase so fast, I'm erasing so fast. Let's take a look at another example, and that would be if I had 3x. That's not true. It'd be 3y plus x is equal to 2, and y minus x is equal to negative 6. Okay, so here I go. Again, I want to isolate a variable so that I can plug in for it. Now, neither of these have either x or y by themselves, so I can go ahead and do that. Now, here's the trick. I can either isolate x or y since we're just used to seeing y isolated, I'm going to go ahead and do that, all right? So I'm going to rewrite this one as y equals, I'm going to add x to both sides, so I'd end up with positive x minus 6. All right? Because the way I got that is I added x to both sides plus x, cancel these bad boys off, and I end up with that. Okay, cool? All right, so here I go. Now that I have this isolated, I'm going to plug in this y equals x minus 6, right here. So I'm going to replace y with x minus 6. So it'll look like this. 3 times, what is y? What is y? It's x minus 6 plus x equals 2. Okay? So now I'm going to use, again, distributive property, and here we go. So I have 3x minus 18 plus x equals 2. So just so we're clear, 3 times x is 3x. 3 times negative 6 is negative 18, and then I have this x just down here. I have this 2 just right here. So now let me put together my like terms. I have a positive 3x and a positive x, or 1x. And what's 3x plus 1x? Well, it's 4x. So I now have 4x minus 18 is equal to 2. I'm going to go ahead and use addition property of equality to cancel that out, to isolate my variable. Bam! And I end up with 4x is equal to 20. Division property of equality, and I end up with x is equal to 5. Okay? So if x equals 5, that means I can plug it in over here to see what the value of y is. So let's go ahead and try it. If I plugged in a 5 here and I said y is equal to, we said x is 5, minus 6, and 5 minus 6 gives me negative 1. Let me just make sure this rings true when I plug it in somewhere else. Let's say I plugged in negative 1 here and plugged in the 5 here. 3 times negative 1 is negative 3, plus 5 gives me positive 2. So it looks like it's working out. The truth is once I have x, you can plug it into this equation, or this equation, or this equation. The truth is that you can plug it in anywhere if you're doing the stuff right. It might be nice to actually plug it in back to one of the originals so that you don't goof anything up. But this is linear systems solving from substitution, which is like my favorite way to solve. There's also another one which is elimination, and there's another way which is graphing, which I don't like, but that's just me. So anyway, I hope this was helpful. I hope you guys are doing awesome. I hope you're loving math in your unicorn way, and peace. Have a great day. Hey guys, so I hope you enjoyed that video on substitution of linear systems. Now, I forgot an amazingly important part. Shame on me, I got so pumped about doing those problems that I forgot to actually talk about what the solution means, okay? And without context, nothing makes any sense. So, shame on me. Sorry about that. The whole idea is that, as I said before, you're doing linear systems to figure out where two lines end up crossing, okay? Let's say if the red represent my coordinate system, this is my xy dealio, and I had one graph that was running this way, bloop, okay, one equation running like this, one equation running like this. The place where they intersect, that's actually what the solution means. So I'm really sorry about not talking about that before. Now in the first one we did, we ended up with the solution of, if I have it correctly, the solution was, I think it was x equaled to 1 and y equaled to 4. And if that's the case, then they actually make an ordered pair, all right? So x is represented as 1, y is represented as 4, so we'd be at 1, 4 is where the two lines cross. Your answer is an ordered pair. So that's the idea. The second one that we did ended up with an answer of x was equal to 5 and y was equal to negative 1. That being the case, then they are an ordered pair. So x is 5, y is negative 1. So I'm really sorry about that, but this is, not sorry, I'm sorry about not putting that in the previous, the video you just watched. So these are your answers. These ordered pairs are your answers, and that's how you should probably be writing your answers for the solution to a linear system is an ordered pair. Because the whole idea, lines are crossing, and you're trying to figure out where exactly are those lines crossing, and they would be crossing at a point on a plane. So I guess that is the idea, and I say to you, peace! Thanks.